Okay.
So, hello everyone. Hi, Jakub.
Hello, Alex. Hello, everyone.
Yeah, sorry for a little delay. We have got some technical issues, but we are good finally, and we can start. So, that's Alex Voloshev, developer advocate at DataStax. Maybe you know me already, but today is a little bit unusual. I will be on the screen, but quiet most of the time because today we have an amazing guest, Jakub Hayek from Traefik Labs. Hi, Jakub, could you please introduce yourself?
Yes, hello, everyone. My name is Jakub Hayek. I work for Traefik Labs. I'm a product adoption specialist, and my responsibility is to providing support for our customers, for enterprise customers, as well as for open source community. So you can find me on Twitter. You can find me in our community forum. And yeah, so I'm very excited that I will be presenting today.
Yeah.
Thank you.
Thank you everyone for joining. Thank you, first of all, Jakub, for joining us today. Kubernetes is on top of the list, is on top of the interests of our company, of course. So, my first point, there is a question, meanwhile, on YouTube chat. What's the duration of a session? So, how long do you think it will take for us to walk through everything what you have for us today?
I think 1 hour will be absolutely enough. So because there will be a little bit of theory, a little bit of slides, and then I will switch to the workshops, to the real hands-on workshop. So I think hour is absolutely maximum that I will use today. I need today.
Great. So I think then let's start.
Okay. I hope you can see my screen. So yeah, today we are going to talk about Kubernetes and Ingress management in Kubernetes with Traefik Proxy. So that's the title of my presentation. Yeah, so as I mentioned, as I already introduced myself, my name is Jakub Hayek. I work for Traefik Labs. I like everything what is related to DevOps, to the Kubernetes. I'm a practitioner of DevOps culture, and I'm an enthusiast of Kubernetes. When I work for Traefik Labs, my responsibility is to support customers, enterprise customers, and open source community, because we have two branches of our core product. That is a Traefik Proxy Community Edition and Traefik Enterprise. Yeah, when I not work for Traefik Labs, I'm a full-time dad. I have a son, and I practice sport wherever I have a time. So this is exactly a few words about myself. If you would like meet me, you can drop me a message on Twitter. You can contact me on GitHub, leave the issue on one of our repositories, or go to the community on our community forum and then leave the message. So there are a lot of channels to interact with me. So that was the agenda of my presentation. So at the beginning, I would like to briefly introduce the architecture of Traefik for those who are not familiar with our product. So we will go through all the configuration aspects. We'll explore static versus dynamic configuration and go through all providers available, but we'll focus mostly on the Kubernetes. As we mentioned at the beginning, that's a standard nowadays. And we as a company, we have currently 3 providers. I mean 3 options to integrate with Kubernetes. So I will try to explore it and explain you which you should choose depending on how advanced is your project. And then after theory, I have a couple of the examples how to deploy Traefik on the on Kubernetes, how to create Ingress resources, and let's move forward. So as I already mentioned, there will be lots of hands-on workshops. So we'll deploy Traefik, we'll go through the dashboard, we'll deploy sample application, and play a little bit with those 3 options of managing Ingress in Kubernetes. So there are a couple of prerequisites, because you can repeat everything what I prepared on your own, or even follow with me. What you just need, you need to have a Kubernetes cluster deployed. You need to have a Helm installed, because we will install Traefik using Helm 3. And yeah, that would be nice to have a domain name that points to your external IP address of your cluster, or any alternative solution like nip.io. That's another domain that you can use it. Okay, so what is the Traefik? So the Traefik, it's a edge router. It's a router that typically acts on the top of your infrastructure, and it provides automatic routing for your services. So as you can see on the diagram from the left side, we have a couple of the example domains with a path prefix, with a subdomains. And if we send HTTP request, Traefik is able to match the routing, is create the routing using the matching rules. It might be HTTP host or even path prefix, and then pass that request to your infrastructure. And as you can see, there are a couple of the available integration. It might be a Kubernetes, it might be a Docker, or it might be even a legacy application, legacy services. I mean VMs, bare metal server, because Traefik also can redirect directly to a specific URL. But now today we are talking about the Kubernetes, so we will have a Traefik provides automatic service discovery. So once you deploy your services on Kubernetes, it will be automatically discovered, and the router, once you create a router, the configuration will be automatically discovered, and Traefik will be able to route incoming HTTP traffic to your infrastructure. Traefik also works with different protocols, not only with HTTP. Of course, it supports and TCP, UDP, gRPC.
Oh,
HTTP and HTTPS. Yeah, besides of that, Traefik provides a lot of features, middlewares to do something with your request, to add specific headers, to remove headers, to add extra, for example, basic authentication, or even more advanced, such as mutual TLS. So lots of available features in that router that, again, acts on the top of your infrastructure and is able to catch the request, process the request, and pass the request to your infrastructure. So as we already know what is the Traefik, we can have a look from the top on the Traefik. What is the configuration? What kind of a configuration types we have in Traefik? So first of all, we have, as I mentioned, static and dynamic configuration. That is very important to understand difference between those two, because the static configuration, that's the configuration that if you change it, it requires restarting your Traefik instance. From the other hand, there are a couple of the available options like routers, services, middlewares that are dynamic. You don't have to do anything. You just need to deploy the configuration, and everything will be automatically applied to your Traefik instance. No need to restart. So those are the crucial information that you remember from that slide, that we have two types of the configuration. First of one is a static, the second is dynamic. We will see later on how it works, what we can do with that, and how it affects our how it impacts our working with Traefik. So here is a slide that I would like to explain you where the Traefik is placed in the entire Kubernetes ecosystem. Because many times, because we support customers, we answer a lot of the questions every day. Many people struggle with understanding the basic concepts of the Kubernetes. Kubernetes is a complex system, so you need to understand the basics in order to understand why we have a Traefik, what is the Ingress controller. So going from the top, we have a Ingress managed load balancer. So if you are running your servers on premises, on bare metal, you probably use Metal LB. This is something that can expose networking outside your cluster, outside Kubernetes cluster. If you use a cloud provider, probably you can use ELB or any other available load balancer. It's happening out of the box. In most cases, you don't have to do anything. Then if you are in Kubernetes, you have a service, you have lots of services, and one of them is a load balancer type. So it's the service that allows you to expose specific ports to that external load balancer. And service is connected with the Ingress controller. And this is actually the place where Traefik is deployed. So it's an Ingress controller. There are lots of available Ingress controller on the market. Today we are talking about the Traefik, and Traefik acts as an Ingress controller. Traefik uses a service, another service that connects with your application, with your pod that are deployed on your cluster. And actually that service only needed when Traefik is making a service discovery. Once the Traefik discover what are the available backends, what are the available pods, it connects with our application using endpoints. So there is no need, so load balancing is managed on that level. There is no need to use a service for that. So this is actually, I wanted to explain that to help you understand where the Traefik is placed. It's a piece of a software that is deployed on your Kubernetes cluster and allows you to expose your services outside your Kubernetes cluster for your users. But in order to manage that, you need to have something that is, again, Ingress managed load balancer. Without that, with a Kubernetes ecosystem, that would be actually very difficult to manage, to expose services. So please bear in mind that ELB from AWS or any other available load balancer, it's crucial to have external IP addresses. And we will see it in a minute in the live demo, how it's designed and how it looks like when we deploy Traefik. So as I mentioned, there are a couple of available options to expose application in Kubernetes. The major difference is that 3 of them, cluster IP, node port, and load balancer, they act in the layer 4. So it understands a little bit of the protocols, but it's layer 4. But if you would like to do much more complicated, create much more complicated solution, we need to use layer 7 because we would like to create a TLS termination. We would like to use HTTP. We would like to use HTTP host headers to, based on that, we can route our traffic to our infrastructure and create much more features that provide Ingress. So in that case, we have to use Ingress controller. So summarizing, we can expose services outside the cluster without Ingress, but we will not be able to do features that I will explain today. So please understand that load balancer, it's a layer 4, but Ingress acts in the layer 7. So if we understand those, I would say, basics of Kubernetes networking, we can ask ourselves how we can integrate Traefik with Kubernetes. So that's actually 3 available providers in Traefik to integrate Traefik with Kubernetes. So first, the most commonly known, it's standard Ingress. So each Kubernetes has an Ingress, and if you deploy an Ingress controller, you can expose the service. But how you can do that? You are using the annotations on specific Kubernetes manifest. You are adding annotations depending of your Ingress configuration. So it will be different for Traefik. It will be different for Ambassador, Nginx, and any other. So it's key value configuration. So it's very hard to maintain. And again, if you prepare the configuration for Traefik, that's no easy way to migrate it to any other Ingress controller. So this is vendor lock-in. It's not good. So most of the companies who works with an Ingress controller, they want to create their own Ingress resources because they don't want to play with the annotations. They would like to create custom resources to create routing, to create TLS store, to manage the routing and provide more declarative way of creating resources. So they invented CRD, custom resource definition. But again, the IngressRoute that we provide, the Ingress resources CRD that we provide for Traefik doesn't work with any other Ingress provider. So still, we have a vendor lock-in. It's easier to maintain, it's much more powerful, but it's still very difficult to migrate in case of any if you have need to use any other Ingress controller. So the evolution of Ingress is following. That entire ecosystem is heading to implement gateway API. So this is actually what Traefik already implements as an experimental feature. And because this is not stable, this is in alpha version, but it works and try to solve those two problems with the Ingress and IngressRoute. So there are no annotations. There are standard objects that you can use it. And it's much easier to maintain further. If you have hundreds of ingresses created, it will be easier to use, for example, gateway API once it will be fully stable. So what is actually that gateway API? So it's the, as I mentioned, new evolution, the future of the Ingress management in Kubernetes, and it has been announced on KubeCon. It has a standardization, because those two that I mentioned, Ingress and CRD, does not provide standardization. It works only with that specific Ingress controller, and it provides role-oriented separation. So you can create specific roles and assign those roles to your application developers and allow them to create specific routing. So that's super powerful feature, because you can delegate some work to your application developers. You can split responsibilities if you manage Kubernetes cluster. So as I mentioned, this is still in the alpha, but it's available. You can deploy on Traefik. We'll see how it works. And you need to deploy some CRDs manually because it's not built in the Kubernetes yet. Currently, it is implemented by 8 vendors for July 2021. And Traefik Proxy implements Gateway API. As I mentioned, it's an experimental feature, but it works. And we also contribute to the project, Gateway API project. So we are up to date with the new features, and we know where that solution is heading to. So how it looks like from the diagram perspective. So on the top, you have a gateway class, and it might be managed by infrastructure provider. Then we have a gateway, and it might be managed by cluster operators. So we can, from that diagram, we can see that we split responsibilities between some of the roles available in our cluster, and we have application developers that can create specific HTTP routes in the specific namespace. So they can create own objects, and they can expose using HTTP route services outside to internet. So that's super powerful. So what are the new resources that have been implemented? What are the new resources that have been implemented? As I mentioned, that's a gateway class. It's a cluster scope resource. Another one is a gateway. So it's an instance of the gateway class. So it's a logical representation of specific Ingress controller that perform routing. And in our case, it will be Traefik. But if you deploy any other Ingress controller, the same routers and HTTP routes should work. So that's the powerful of that gateway API. And again, as I mentioned, it's not stable yet. It's experimental feature, and we will try to see how it works today. Actually, we'll see how it works those 3 available providers: Kubernetes Ingress, Kubernetes IngressRoute, and Gateway API. So that's all about the slides. Let me now switch to my console, and let me deploy Traefik, and let's play a little bit with a hands-on workshop. So as you can see, I am already in my terminal, and I'm connected to one of the Kubernetes clusters that I just created before that meetup. There are actually installed standard deployment, standard pods that are required to have a cluster up and running. There is no any services yet exposed. So I'm connected to it. It's created on AWS. So let me first deploy Traefik, because I created a couple of examples here. So the first step will be to deploying traffic on that cluster. So how to do that? We can just create Helm install traffic, and we should be able to deploy traffic on our Kubernetes. So pretty simple command. It should deploy the cluster. As you can see, it's already deployed, and I haven't configured anything. I just only add my repo to my Helm, so Helm was able to deploy it. And now, as you can see, it's already deployed with a standard configuration, with a default configuration. So let's see what's happening. As you can see, traffic has been just started. This one pod has been just running. Let's explore what has been installed here using that simple command. So let's explore the services. And as you can see, that's the external IP address that has been just created. It connects, actually, it exposes my traffic outside my Kubernetes cluster. And it is happening thanks to AWS, because if we deploy our Kubernetes on bare metal, we should find a different solution, for example, Metal LB. So all of our applications that we will deploy today will be available through that IP address. So let's explore a little bit what else has been installed. So we can create, we can execute command kubectl describe deployment traffic, and let's see what specific parameters has been added to our deployment. So as you can see, we have an entry point. So those ports allow us to expose traffic outside. Actually, those ports listening, where the traffic is listening to. So as you can see, there is a specific port that are used for HTTP and HTTPS. We have a provider Kubernetes CRD available by default, or Kubernetes Ingress available by default, and no any other configuration. So traffic is up and running. So let's see what we can do further with that. So let's go to the exploring dashboard, and here we can create port forwarding, because traffic create one ingress route to expose traffic dashboard. This is actually deployed by default. So we can execute port forwarding specific command that will forward our connections from my local computer to the pod that is deployed on the Kubernetes cluster. So let me deploy it. Let me execute that command. And now if we go to the local host 9000, we should see the dashboard is up and running. Yes, so as you can see, the dashboard has been is available. We have two available providers, so Kubernetes Ingress, Kubernetes CRD. Some routers already are created by default, so specific routers that allows us to see the dashboard, because that's the internal routing. As you can see, we redirect everything to that specific service. Pinged as this is the health check, because we would like to make sure, we would like to check the condition of traffic in case of problems. Kubernetes will automatically recycle the traffic using aliveness and readiness props. So this is actually what's installed by default. So nothing actually special here. Just you can see that it's working without any extra configuration.
By the way, sorry, I want to add a thing here. For people who are not used to the different ingresses, traffic control in Kubernetes and so on, that may look like something obvious. Okay, where is the dashboard, routed services, all cool, yeah, all great. Like, okay, that's like that with every Ingress controller, right? Wrong. So yes, I have experience with different Kubernetes Ingress controllers. In the beginning, I used to go with Nginx, because I have pretty strong experience with Nginx before. Yes. But if I would run any project on Kubernetes right now, this control panel is like one of the best reasons for me to go with Traefik, because I can really clearly understand what is going on, how it's configured, and how it works. So well done, people. Really.
Thank you, Alex, for that note. Yeah, that's very nice to hear that. Definitely, I like dashboard very much, and I use that on daily basis, because I can see what's happening with my routers, how it's designed. And you will see in a second when I will be when I will be deploying any application, everything will be automatically available here. So it's super powerful, super useful. And of course, there is also API available. So if we go to the API raw data, we should see API. Yeah, I will check it in a second. So we have also API, because that based on the API that is available, the dashboard based on the responses from API. So yeah, let's move forward, because we would like to see the differences between Ingress CRD and Gateway API. So we need to deploy sample application. So I will deploy simple service that is called Who Am I. It's very simple application that just expose headers from the inside the container. So let me deploy it. Okay, apply -f Who Am I deployment. It is creating. It will take a second. Yes, it's up and running. Now we need a service. So that service, if you remember my slides, to connect traffic with a pod. So we use a selector to expose port 80 from that container, from that pod. So let me apply it. Who am I? Service. So that has been created. Let me check it. Yes, that's available here. Now let's try to use endpoints to see whether traffic was, yes. So endpoints, Kubernetes endpoints has been created, and now we can reach our Who Am I application from the inside the cluster using that name or that IP address, because that's the cluster IP address. So we expose our application inside the cluster using one of the available options in Kubernetes, that is a cluster IP. However, that application is not exposed for our external users. So now that's why we need to have Ingress to do that. So let's move forward to the 04 and let's create simple. Before do that, we need to create DNS entry, because now the domain that I'm going to use to present our application will be mtraefiklabs.tech. So I need to use that IP address, that external IP address, and update wildcard DNS, wildcard record in my DNS provider to point to that IP address. So the domain traefiklabs.tech it's hosted on Cloudflare. So I have a very simple script that will connect to the Cloudflare API and will update DNS entries to use that IP address. So let me execute that script. It should take a few seconds. Yes, it creates, as you can see, CNAME record with an asterisk here, demo traefiklabs.tech, and the content, the value for that CNAME is actually that long IP, that long name from AWS. So now it will take probably 2 minutes to be propagated over the internet, but we can go to the another example and to expose the application. So please note that we use demo traefiklabs.tech. So each record, each entry that we'll add it here will point to our Kubernetes cluster and actually inside to traffic. So let me open it. I played with that on the test cluster here. So let me change the name here. So that's the standard Ingress. So probably you've seen that manifest many times. It's V1 right now, so it's stable. Finally, it's stable, and it used those annotation that I mentioned. So what that annotation means, it means that we would like to expose our Who Am I application, that sample application, through entry point web, through HTTP. And the matching rules will be used for following. So the host, Who Am I, demo traefiklabs.tech, path, prefix. So we use the path root, and we redirect our request to the service Who Am I SVC. So let me deploy it. Okay, apply -f ingress web. So yes, it has been deployed. Let's go. Let's first check if whether it has been deployed. Yes, it has been deployed in default namespace. As you can see, the name of that ingress is whoami-http, and that's the host that we are going to use, and it's available on the port 80. Let's go to dashboard and to see what has been changed. So as you can see, now the new record, new entry has been added here. It's a whoami demo traefilklabs.tech, path prefix root, and also the new service. So this is the new service that has been created. Provider is Kubernetes. We can go to that and to see that the only one pod is available, one backend is available here. That is actually true because we deployed the only one replica here. So now we should, if we go to that URL, we should be able to whoami demo traefilklabs.tech to see the application. It works correctly. We get the response. We can check the HTTP headers. Yes, so the response is 200. That means that we reached the application and we received the response. So what we have done right now, we added the Kubernetes Ingress object that I just presented. Let me display it once again. Ingress. So we created that object on our Kubernetes cluster, and thanks to the standard Ingress implementation in Kubernetes, we were able to route traffic, HTTP traffic, to our pod in our Kubernetes cluster using that specific annotation. And of course, it seems to be easy right now, but you will see in a few minutes that I will be adding more annotations and it will become more difficult. And I will just add a few of them, but if you create more advanced ingresses, it might be complicated, especially if you have a number of much more ingresses created. So let's further to another lesson. And now we would like to update our traffic configuration to use specific values. What does it mean? Because as I mentioned, at the beginning, we deployed traffic using Helm, right? I haven't created any specific configuration here. But traffic, I'm here on our official repository, traffic Helm chart. And as you can see, there is a file values. Because traffic has lots of available options that you can configure it, especially if you would like to use, for example, Let's Encrypt or any other specific features. I did it by purpose. I didn't install those configuration at the beginning because I wanted to show you that with a very simple command, Helm install traffic, you can easily start to explore traffic. So let me go to values.yaml just to briefly review what is available here, what options we can do. So the entire section of the deployment, Ingress classes, experimental features, providers, Kubernetes CRD, volumes, additional volumes, many features that are available. So this is actually what provides our default, our Helm chart. So what I'm adding here, what I would like to have logs, general, available, log level is info, access log enabled, true format JSON, and I will passing specific additional arguments here because Traefik has a built-in feature to automatically issue certificates from Let's Encrypt and renew them before the expiration date. So there, I added here two servers, staging and production. So, and we use TLS challenge because if you are familiar with a Let's Encrypt, we need to somehow prove that we are owner of the domain that I just created. That domain demo traffic tech lab. So we need to prove to the Acme, hey, that's my domain. So we will use TLS challenge. So there are other two options, HTTP challenge and DNS challenge. But in my case, I will use TLS challenge. And we use any IP, any email address to identify that we are the owner, that actually to create account on Acme. And we need to also create persistent storage in order to keep our certificates, because in our example, Traefik will be stored certificates on the persistent volume on Kubernetes. It will create PVC, and all those certificates will be stored in that acme.json file. So that's file that I prepared before the workshops, but you can explore much more options here. So let me deploy it. Yes, so we will use the following command, helm upgrade -- install Traefik. We identify the repository and the file with the values. So it will take a few seconds that it has been deployed. We can see that now Traefik is being restarted. So as you can see, it's terminating. We see the error here. So let me click Ctrl+C and let's check a second. Let's check a second. Container is being created, so we can describe what has been changed in our deployment. Yes, so as you can see, there is much more arguments that are part of the static configuration here to work with Traefik. So we have a certificate resolvers, we have a log level info, access log. So those parameters, additional arguments that I added to the values.yaml are passed here. So since it's working, let me check the SVC again. Yeah, that's available. And the PVC, because as you can see, Traefik created physical volume in my cluster, and that volume is mounted to the Kubernetes to that pod. So we can go to Traefik sh and go to the data, and that's the acme.json file. Currently is empty, but now we'll try to issue certificates for the domain. That certificates will be stored here. Yeah, so let's move forward 06, and now we will use very similar resource, but we will, as you can see, we're now adding two more annotations. So we are again create Ingress resource, who am I HTTPS. We are adding the entry point web secure, because we would like to expose our application, who am I, the same application on the HTTPS. So we use a TLS true and certificate resolver LE. So this is actually what I created in my here, right? Because the name is LE staging or LE. So we use a production. So let me go to the dashboard. Okay, we need to create port forwarding once again. Yes, so dashboard is back again. And now let's deploy Ingress Web Secure. Yes, as you can see, it has been just created. The new entry just appeared here. Based on that icon, we can assume that it's a TLS termination available for that. And let's go to see what's, yeah, and we have information here that it used TLS and the certificate resolver is LE. So let me now check ING once again. Yes, we have two resources available, and we need to update that because that's wrong. I need to update the domain -ingress web secure get pods get ing. Yes, it has been updated, and also our our configuration has been also updated here. So let's wait a second. Once Traefik issues certificates, hopefully everything should work correctly. Curl HTTP. Yes, so now we are hitting still the same Ingress that we have created a few minutes ago. But now, as you can see, I switched the protocol to HTTPS, and I haven't received any warning. That means that curl was able to reach my Traefik instance with a valid certificate. So let's review. Let's have a look what certificates are presented thanks to Traefik. Yes, so we have a common name here, who am I am demo traefiklabs.tech. It's let's encrypt, it's valid, it's verified correctly. So it means that our application works correctly through HTTPS. And now let's try to verify through SSL Labs what is the quality of that certificate. So let's go to let's use the domain. Let's create HTTPS. Okay, and let's click submit. It will be running in the background and we will move forward with the presentation.
Yep, and it will take some time. But yeah, I'm very curious about the expected results. It's a great tool, by the way, if you have to work from time to time with SSL, TLS connections.
Exactly.
Link is like the #1 for me to test the TLS setup on my side.
Yes. With the default configuration, we will receive grades. You will see what grades we will receive. But then we'll tune the configuration and we will enhance our security just using specific headers thanks to Traefik. So we'll see in a second how we can tune our configuration. So summarizing, we have a two application, HTTP and available on the HTTP and HTTPS. And now let's move forward to create redirection between those, because now we would like to redirect from HTTP to HTTPS automatically, because now we have a duplicate content because the same application is available through different actual links, but the content is the same. So we need to create a redirect scheme specific middleware and assign that middleware to our routers. So that's the actually one of the custom resources provided by Traefik, and the name is middleware. So what that middleware does, it creates redirection from HTTP to HTTPS. And if you explore the Traefik's configuration documentation, you will see there is hundreds of maybe not hundreds, there's a lot of available middleware. So that's one of them, just an example. So let me apply it. Redirect scheme has been created. kubectl get middlewares. It has been created 6 seconds ago. And as you can see here in the tab, we can see that middleware has been created. What I would like you to remember from that Kubernetes, actually there is a specific convention name. We created the redirect scheme. That's the name of our middleware. However, we use the following convention name. So we have a default is the namespace, Kubernetes namespace dash redirect scheme. That's the name of the middleware and the Kubernetes and the provider, and that fact is the Kubernetes CRD. So that's very important to remember, because that name we have to use in our configuration further. There are sometimes questions, it doesn't work, my middleware is not reachable because the name is not correctly added. And I would like you to remember that that's the correct naming convention. Namespace, middleware name, at provider, because you can use a file provider, you can define the middleware in the file, because Traefik has more providers. So yeah, that's what you like to remember.
Yeah, and
yes, Alex?
Name looks not important as long as you don't run into serious troubles because of name collisions and just bad names. So listen to Jakub, he's telling very important things. Naming conventions are important. I have a couple of things to say meanwhile. First of all, there is a message on YouTube chat I believe you will really like. Some warm words from Akmal. Imho Traefik is an industry standard now, literally beats any solution out there. So why not to use something that simplifies our life, right? And well, I'm completely with Akmal on that.
Thank you very much. That's very nice to hear that. I will tell my teammates that you like it. Thank you very much.
Yeah, I will make a screenshot and send it to you, Jakub. Then,
perfect. Yeah, thank you.
Second one, a question from Vimal. Can we have GitHub repo for today's workshop? My help to work on Ingress once learn Kubernetes and Docker.
Absolutely. I will just share the repository after on Twitter. And even with the question that will be, if there will be any questions, we can compile all answers together and send send the link to the GitHub repo.
If it's already available on GitHub, you can send link to me right now, and I will send it.
It's available, but a little bit, yes, because I created similar workshops earlier, and it's available on my GitHub repo, Jakub Hayek, Traefik workshops, and there are all exercises here.
Okay.
But yes, you can use that, but here is the latest version, just updated version that I prepared before, especially for that event. So you can use that, GitHub, Jakub Hayek, Traefik-workshops, or wait a few minutes and I will share the latest version on the new.
Okay, so meanwhile, I will send this one. So we will have first one first. And one more thing. We are almost done. Sorry for interrupting you, but I've pasted it in the YouTube chat, but I want to repeat it. Thank you for joining us today, and Traefik has a special raffle for you, so you can participate. I'm sending the link to participate to that on the YouTube chat right now, and there is a chance to win a $50 gift certificate by simply watching this talk and filling the form. Link is in the chat live right now.
Yeah. Okay. Can we go further?
Yeah, I'm done. Sorry.
Yeah, no worries, Alex. Thanks a lot. So, as you can see, we created middleware. That's the middleware that has been created. Now we need to assign that middleware to our router. And how to do that? Again, using annotations. So we have the same HTTP Ingress, but we are adding the annotation here. And yeah, let's apply it. Okay, apply -f Ingress web. Yes, it has been configured, so something has been changed. Let's go to see our router here. And as you can see now, it is as middleware has been assigned. So that's the name, that's the type, and that's the provider. It's from Kubernetes CRD. As I mentioned, you can have many middlewares in file, in static classic configuration file using as a config map on Kubernetes. So you will refer to the file if you create your middleware in a file. So what it does, that middleware, it should redirect from HTTP to HTTPS. So let me try to do that. So I'm sending HTTP request to HTTP, and I'm a move permanently. So let me -L, and I was redirected to the application. So as you can see, now it works. We don't have duplicate content. We redirect from HTTP to HTTPS using one of the example middlewares. Let's move forward. So very simple example, but I will go to services to see how the automatic service discovery looks like. As you can see, we have just only one pod deployed here. So let me scale that deployment by creating, let's say 3-4 replicas. So as you can see, containers are just created. Let's add watch here, and we should see that those containers are available here. Let me refresh it. Yes, as you can see, those new containers, new pods has been added here. So now the load balancer on Traefik will be sending requests to those 4 pods. There are no any change on my side. If you use horizontal pod autoscaler, that job will be done automatically. You don't have to change anything on Traefik. That's the dynamic change on Traefik. So we can scale up, let's say, to 2, and the same should happen in a few seconds, that we will be able to see that there are 3 and there are 2 available. So this is how it works from Traefik. Let's go to the IngressRoute. So we explored standard Kubernetes Ingress, and now we will expose the same application who am I, but using new Ingress CRD, IngressRoute implementation directive from Traefik. So as you can see, I'm using custom resources. The Traefik containers is still in alpha. IngressRoute, who am I CRD, rule, matching rule will be host, CRD, and let's change the name here. And we will have that what does that configuration, what does it mean, what we created here? So our application CRDM demo Traefilk will be available through HTTP, and everything will be passed to that service. So let me deploy it and to see what will happen. Ingress CRD created. Let's go to dashboard. And as you can see, it has been just created here, CRDM demo Traefilk and the provider is Kubernetes. We can go there. Yeah, there are no any TLS, no middlewares, just simple HTTP CRDM demo Traefilk Yes, and you have the same response, the same application. So our application Who Am I is available through Kubernetes Ingress as well as through Kubernetes Ingress CRD. And now let's do some more advanced configuration, because we will create CRD web secure and assign more features from Traefik. So you can see that I'm creating IngressRoute object here, but I'm adding the entry point web secure, and the matching rule is a little more difficult because we will use a OR. So you can create the configuration that the same service will be available through two hosts, through two separate domains, and we will assign some specific middlewares security. We will assign new certificate resolver LE, and we'll create two SANs here. So our certificate that will be issued from Let's Encrypt will have two common names, alternative and the main. And we are also assigning specific TLS options because, as I mentioned, we would like to tune our configuration. So we are adding what is the minimum version of TLS, what are the specific cipher suits that we are going to use, what curve preferences we are. So it's quite difficult, but it tunes our configuration. SNI, we're enabling SNI and adding some specific security headers. So frame deny, SSL redirect true, and much more security headers. Definitely, I will create separate session about those headers because they are quite difficult, but very useful. So without thinking more about it, let's try to deploy it. I just double check that there are no any typo here. Yeah, it seems good. Let me deploy it. Ingress Web Secure. It has been created. And as you can see, it has been created also in dashboard. So we have a specific icon here. And as you can see, we have two alternative domains. We have more security headers available here. And yeah, it should be available now through HTTP as CRDM demo Traefik Lab. I think the certificate should be already issued. It's not yet issued. Let's wait a second. Yes, it's already issued. As you can see, it took a few seconds to issue certificates because the first request failed, but the second is successful. So we can check exactly what's here. So we have a certificate CRDM, and we have also alternative name here available. That was probably CRDA. Yeah, CRDA. So this is exactly how it works. So now let's go again to SSL Labs because we exposed the same application on the server, Who Am I, but using different URLs, different CRDA demo Traefik Labs.tech. But the difference is that on that actually URL, unable to resolve domain name. Of course, that's the issue here. That's the typo here. So, but on that domain, we added much more security headers. So we suspect we would like to have more better grades. So it will take a second, and we'll just compare it. Let's let it run it in the background, and now we'll create basic authentication middleware, because what we can do, let me remove some mess from here. And Traefik is able to, of course, one of the example middlewares is basic authentication, so we can create simple password and username and password using standard HTTP password command. So we have it out here. So we generated a string with an encoded password. Now we will create Kubernetes secret from that file. Get secrets. Yes, it has been created. -o JSON data user. It's not user. It's password. Let's check YAML. Yes, so we have, yeah, of course, admin secret. Yes, that's out. Admin secret. Out. Yeah, so we have some data here encoded. Base 64-D. Yeah, admin and our password here. And now we can create middleware, another middleware. The name will be test out, and we will refer to the Kubernetes secret that we have just created. So let's go to middlewares. Okay, create. Okay, apply. -f middleware basic authentication. Yeah, middleware has been created. It's available here. And now we can use that middleware to protect one of our websites. So let's go to another example here, and we will create specific router here for our dashboard, because as you can see, the dashboard is still available through the port forwarding, but let's imagine that we would like to expose the dashboard to our developers and give them access. So, but we would like to protect them. So in that case, we use a very simple basic authentication, but we can create OpenID Connect. We can create many authentications. We can use many authentication strategies to authenticate to the specific resources. So now we use a very simple configuration. So let me deploy it. Let me double check once again. DM, yeah, a little more operators here, path prefix dashboard, path prefix API internal, and we redirect internally to the Traefik's API. We're assigning that middleware and use certificate resolver LE. Let me apply it. Ingress CRD created. Let's see what's happening here. It's available. Let's encrypt, and it's already added here. So let's wait a few seconds, because it will take a few seconds to issue certificates, but let's compare SSL tests that we ran at the beginning. So at the beginning, I deployed WhoAmI application using Ingress, standard Ingress, without adding any extra headers. And as you can see, SSL Labs give us a grade B, so we should think about how to tune a little bit. So we have done the same. We exposed the same application, but using different URL and add specific security headers. And as you can see, we have an A+ here. So that's very good results. We still have some place to improvements, but it looks much better comparing to the default installation. Yeah. So I think certificates should be already generated. Let me go to HTTPS dashboard. Yes, as you can see now, I have a prompt to put my username and password, the same password that I created on in that Kubernetes secret. So it's admin and password. And the same dashboard is available here, right? So it's everything that we have prepared so far, but now it's available through public URL. So we can stop the port forwarding. We can actually close that session, and yeah, that's available. That's no longer needed, and we are available here. Okay. And now, yes?
There is a good question, but maybe you want to finish this part first.
Yeah, please go ahead.
Okay, so question from TH Donatella. Good one. What about metrics for Prometheus? I want to know upstreams latency and other metrics from Traefik,
Yes.
and then normal monitoring, Grafana, and so on.
Absolutely. Yeah, so in that repository, because today I'm not going to present Prometheus, but in that repository, Traefik Workshop, if you will go to the lesson 15, you will see entire tutorial how to deploy Prometheus stack using their Prometheus community chart, and what needs to be done on the Traefik level, what you needs to be done on what you needs to add to the values.yaml in order to create to have a Prometheus and Grafana deployed. So here is everything. There is a service monitors, right? There is a service monitor, specific labels to match the traffic and traffic dashboard. Because by default, Traefik expose metrics. And yeah, so that's the answer for your question. Just follow the tutorial, and I'm sure you will be able to monitor, to get the metrics and visualize them in your Grafana. Because here, even I'm injecting the example dashboard, that's the JSON format here. Again, I'm passing that file to Prometheus stack while I'm deploying using Helm with those specific extra parameters. So extra plugin, pie chart, dashboard provider, and there is also a sample Traefik dashboard. I hope that answered your question. Yes, so the last one is Gateway API. So it's a little bit more complicated. And again, please note that this is the experimental feature. It's not yet stable. It will be stable hopefully soon. I like it very much. Let me deploy some example configuration. What we have to do first, we need to deploy specific CRDs. So if you go to that URL, that's the standard, that's the GitHub apps. That's the GitHub repo, github.com, Kubernetes 6. Why it's not working? Kubernetes. Not keep spray, but 6 gateway API. Yeah. If you go to the gateway API on GitHub repo, you will see that the latest version, latest release is 0.3.0. So you need to deploy manually CRDs, as we mentioned during the presentations. How to do that? CRDs are available here. So that's the customization object here. So you can deploy it using that simple command. It will automatically download all necessary, all needed CRDs. As you can see, it's being created, Kaget CRDs, and we have a couple of the new CRDs that we can use to play with the routing. Again, that's the new evolution, that's the future, but definitely we should think about it, we should explore it, we should learn it. So That's how it works. The CRDs are deployed. Now we need to deploy traffic with the new configuration. So what I'm adding here, I'm adding experimental feature Kubernetes gateway enabled true. Why I'm adding here, because there is I'm again in my Helm chart, and there is where is it? Experimental features. I need to enable on traffic is experimental feature, and I need to redeploy it. So experimental Kubernetes gateway enabled true. Install, yes. So Helm upgrade install traffic dash values YAML dash f values.yam. It will take a while. Traffic should be restarted. Yes, it's being restarted. Describe. Let's wait a second. And as you can see now, because I added new parameters to the values.yaml, and new arguments are added. So Kubernetes gateway and the experimental Kubernetes gateway. Let me go to the dashboard. I think it should be already up and running. Not yet. Yes, it's running. Not yet. Liveness and readiness props. Okay, it's up and running. So now we should refresh. Let's wait a second. Okay. We shouldn't expect the issue here. Yes, okay. Now it's better. Because by default, when the acme.json file is not loaded to the traffic will serve the default certificate. It's better to have a certificate than does not have any certificate. So in that case, traffic present the default certificate, because loading that file acme.json took a while. So now it's available. And as you can see, we have another providers available. So we have Ingress, CRD, and Kubernetes gateway. Let me deploy it, a new object here. And that's the new CRD, new object HTTP route that will deploy simple application. Actually, that will deploy routing for the same application. As you can see, it's quite similar to the Ingress, but it's quite different. So we use specific rules. We have a host names, and it doesn't matter what kind of Ingress controller you use. It should work with traffic and also with any other Ingress controller. Let me deploy it. It has been deployed. Get HTTP routes. As you can see, it's added 5 seconds ago. Let's go to dashboard. And yes, that's added here. W2, W3. Yes, so we should go to curl HTTP wt and demo Traefik Labs.tech. And the application is available. It should be also available through W3. Yes, it is. Yes, so I think that's all what I prepared for today. Let me summarize a little bit. We explored Kubernetes Ingress. We explored Kubernetes CRD. We explored Gateway API, new evolution. So there are 3 types of the Kubernetes Ingress management implemented in traffic. You should ask yourself, what should you choose to if you play with the environment? Again, it depends of how large environment you have. When I'm deploying a new environment, I prefer to use CRD because there is much more powerful. I'm familiar with them, and it gives me a lot of flexibility. So I strongly encourage you to explore our documentation, docstraffic.io, to learn more about the available options. If I'm managing the environment that are already some Ingress objects created, probably I would stay with a standard Ingress implementation and use that annotation that I presented at the beginning. But again, it depends on the use case and how large is your structure. how large is your environment, and how many objects you have created. Okay, so that's all what I prepared for today.
That's amazing. That's a lot. And thank you so much for joining us today. Thank you to all of the attendees for the great questions. Now we have two special news, two prizes. First of all, so as Traefik and DataStax are big friends in on the Kubernetes field, both Traefik and DataStax provided some special prizes for you, or some valuables for you to get. I pasted the link for the Traefik raffle already, and I will do it again in a moment. And right now there is a certification voucher claim form from DataStax. Certification voucher means what we sponsor your education and certification for Apache Cassandra as Apache Cassandra developer or administrator, and you can pass our courses for free at the academy.datastax.com, datastax.com, right? And then pass the exam with a normal price of $150 or something like that. With this voucher, you pass this exam for free, so that may be your big chance to get your NoSQL certification without paying a single cent. And that's an amazing thing. And let me copy paste one more thing for the Traefik raffle. Boom, 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 boom. It's done. Okay, so there is many thanks from Stephen Madison. Excellent work, gentlemen. Many thanks from Traefik Labs, Donatella, me, and many dozens of people were with us today, and that's amazing. And I hope even more people will watch the recording. And I believe that's it for today. If you have any questions for Jakub, ask them right now or stay quiet forever. No, just kidding. You still can ask them later.
Yeah, definitely. You can reach me, as I mentioned, in the social media, in Twitter, LinkedIn, GitHub, whatever channel you prefer. I'm happy to help you and support you with deploying traffic.
Yep.
Thank you a lot, Alex, for organizing the meeting. That was so nice to attend, to share, to give the presentation, and that was so nice. Thank you a lot for organizing that.
Yeah, thank you. Thank you, first of all, for talking. We will be happy to host you again in case you will have something new for us.
Yeah.
No questions. We will be happy to have you here again. And thank you so much. So, everyone, we wish you the best of the best this week, and a little bit of music for you in the end to enjoy if it's your morning or day or whatever evening, like for me. See you again later and have a great week. Ciao, everyone.
See you. Thank you.